centralized unit, right? For CPX APA, it will become like a modular or centralized unit like this. So as you can see here, this is decentralized, and then we have a modular one. So this is to replace our old CPX classic system. But as mentioned just now, we still can't fully replace it yet, because a lot of the I/O module are still not released. Like we still do not have an analog output or the NPN digital input or NPN digital output. But basically right now we will start to see a lot of new sales, which is about why every time I start the trading, there's someone look for me. It's okay. So like basically, like for example, Vietnam, you also have a few cases which is about the CPX API or VTOX, right? So these are all the I mean lately we will see a lot of support regarding this kind of module. Okay. So then let's see where this is the last cycle. This is the same as the CPX API. We have the same thing like the topology, compatibility, blah blah blah. Okay, not important. So why AP is because lower cost and higher performance. Then we have integration for all common PLC. With like we mentioned just now, the EtherCAT, Profinet, Ethernet IP, and Modbus TCP. And also this is our new products, future products, and there will be a lot of improvement on it, such as like we will have predictive maintenance, because for VTUX we would have like a life cycle there, product life, so the WAF life cycle. So every time you trigger it, right, the life cycle will count, and then did Yikai mention this yesterday? So for VTUX, right? Previously we couldn't do that with our old WAF terminal, but when we use with VTUX, especially on the parallel one, we have two. Serial. We have two, right? Serial and parallel. Okay. For serial, right, you can read a lot of more information. So one of the things for serial is that we can set what is the life cycle for the WAF. So for example, we set it as 100,000. After the WAF have turned on and off for 100,000 times, it will give us a warning. So maybe that's the time that you can do like performance preventive maintenance, like maybe replace the WAF or something like that. So this is the things that if let's say we can only do it with EPCOM, but if let's say we are using the old CBus, right, the communication is already so limited, so we can't get more additional information like this. So same like when we have VTUX, right? Yesterday also, I think Yikai also mentioned that we could have attached a vacuum generator there. So with vacuum generator, you could do a lot of configuration when you are using parallel, and all this is possible because we are using EPCOM communication. If let's say you are using the CBus, the old one, with such limited bytes, there's a lot of things that we couldn't control. Okay, so that's why we need to use AP. And basically you see here for CPX AP, right, the set just up, it's not just that we can only use with VTUX, you can also use with certain WAF terminal like the VTSA, okay, or the NBAS WAF terminal. But of course, when you are using with this WAF terminal, it is converting from AP to CBus, because these WAF terminals are still using this old CBus. Some we have the new technology, but some is still using the old one. But if we are using the old one, then there's still some limitation on the WAF side. Okay. Okay, so this is our WAF terminal. Okay, this EPLI is already released. You can see it there. So as mentioned, as you can see here, when we have this, right, this means that we need to have a few bus. Okay, but just now we did mention that, okay, for the CPX APA, okay, for AP we can have up to 79 modules. Okay, but for APA you can only have like up to 15 modules per terminal. Okay, but there is still a capability for your for your AP few bus, right, to communicate with more modules. But due to, I think, its mechanical limit, you can only have up to 15 modules. So what you can do here is, you can have another set of this APA down here, but without using a fuse bus. Instead of fuse bus, you use the EPLI, which is maybe you guys can come over here because I think I can't take it out. Yeah.
Sao hình rất dữ vậy mơ?
Hả?
Dưới cái bộ đó thôi. Dưới
This
cái
is
bộ
the EPLI. So
Set nhắn không?
yeah, so what it does is like it's actually like the just how we mentioned like VTUX we can communicate with AP communication also, right? So this one is like you are just connecting like basically, for example, if let's say this set of I/O module, it can be attached here also, but if let's say you have already reached the limit of 50 module, okay, like 50 module, but you still want to add additional I/O, but you don't want to add the fuse bus interface because fuse bus interface is much more expensive compared to like just I/O module. Like I think the price is two times or 3 times higher than the I/O module. Yeah, that's why we can use this. So this is not a fuse bus interface. Okay, it's a AP interface. So what you can do is just from here you have an AP communication. So this port, I think last week someone one of you asked about what's the function of this port, right? This port is actually the AP communication. Okay, so because for APA, when you connected your I/O module here, this is AP communication. I mean this is AP communicated, but you can have the AP com here connect out to like another this AP interface for you to increase your I/O module count. Or you can also connect this one. You can also connect to the API. Because for example, you see API here, we have a power supply port and the AP-com port. So for this port, you can connect to the AP-com port. Then you can have additional like the decentralized unit to use together with your APA module. Like
so does it have any limit for the connection for each?
Same
Still,
like the
like 79.
79, yes. So that means like if let's say you have like 5 modules here, right? Okay. Then you can have you can go out to like up to like 75. Yes, correct. Or you can connect to like this, but the thing is it's the same, 70 you can up to 75, but we have a limitation of each set, right? You can only have up to I think 15 as mentioned just now. Okay, it's clear?
Yeah.
All right. But the modules numbers, no worries. I think it's all available on.
Joyce mới nhắn rồi.
You can find them in the catalog. Okay. So then, as you can see here, you can either just put an end plate to end this CBS APA, or you could connect to a pneumatic interface, which is an MPAS, or you can connect to VTUX or VTSA. Okay, so all this is you need some module, right, to attach it to the CBS APA. So when they're connected together, they will become like CBS APA, VTUX, and CBS APA. So the front part, the remote I/O part is CBS APA, but the WAF part is MPAS. So same like this is CBS APA and VTUX. Okay? Yep. Okay. So these are not coming soon anymore because it's already released, and this is an old slide, that's why it's still already coming soon. Okay, so then we have the bus interface, same like the CBS API. There is some slightly different is that, okay, if let's say we have a CBS API, right? We have an EP, and I want to switch to EC. I would need to switch the whole module, everything, right, together with the power supply, everything. But if let's say I have a EC here, I want to change to PN. I just need to take the upper module here. The sub-base is the same. It's a modular for everyone. You just need to take up the
interface.
Yeah, the interface, and then you can change to whatever interface, right? Then your whole I/O module can be used for that interface already. Okay, yeah. Okay. Also, one thing about what's it called, the I/O module, right? Later you can try to take up one of it, right? You try to disassemble it and play it. It works like a Lego. I mean, of course, not as fragile as Lego. But for example, if let's say I want to add, like customer today, he has a for DI only have DI module. He wanted to add a digital output module. It's very easy. Later you guys can try, right? It's very easy for you to just like detach it and then add a DO module and then install it back. Yeah, it's just like like Lego. It's very easy for you to plug and play. Same goes to when let's say they have a lot of module, they want to remove something. Yeah, then it's very easy for them to do that. Yeah, later you can give it a try. But of course, there's still a screw inside that maybe they need to buy the screw and then put in the correct because.
They need to buy the screw also.
Yes, if let's say depends because if let's say your screw length is enough, then you do have to buy additional screw. But let's say if it's not enough, then maybe you need to change the screw inside. Yeah. The screw I'm talking about, there is like a screw, how to say that, there's a horizontal screw like this for you to connect all the unit together. Yeah. So that's the screw that later you can take one of it out and then you give it a try.
I thought it just was each
sorry,
module.
okay, my bad.
Not here, right?
It's not here. The WAF has the screw.
Yes.
The VTUS has the screw. The CBase AP no. So CBase AP is
Just the bus?
yeah. There's a screw
Just for
here.
one for each.
Yes,
Yeah.
when you buy it, it will come together and then you can just install it.
Yeah,
Later
okay.
you can give it a try. Okay. Yeah. The screw I'm talking about is for VTUS. So when you have more WAF, right, you need to add the screw. You might need to add the screw. Okay, so then we have the power supply. Down here, the base. All this is just different standard. Like we have M18, M12, L5 pin or whatever, depending on what customer want to use. Then the difference is that this is a single supply. Then we have something called forwarding supply. Forwarding supply means that there is an in and then there's out. So the out is that so that you could connect the out to another APM module, or you could connect it to like the API. Okay. Then you could also have additional supply. So additional supply means that because just now we also mentioned like this is there's a limit of up to 16 amp. Okay. But if let's say customer use like too much, it's not enough, right? Then up behind it they can add another additional supply for the WAF or for the digital output here. Okay. Yeah, these are the modules that we currently have. I think some of the coming soon is already released. Okay, for digital input and output. Okay, for analog input, let me see. I think we already have the analog input, but again, we still have let's see. Okay, we have the analog input module. Okay. But the thing is, why we say we still can't completely replace the CBS is because we still do not have an analog output. Okay, then yeah, same thing like just now the API. Basically, these are just a future development. We are not sure when they will have it yet. Yeah, about this, for EPL we have two different types, whether it's EPLI or EPLI-S. So the difference is just that whether it has a power supply output. So you see there's APE, APR, APE, APR, there's a power supply in and the power supply out. So this one we have only power supply. It should be power supply in, I believe. Maybe I think it's written wrongly here. Okay, then. Okay, according to this, they are planning to have multi-protocol for our CBase API also, but we are not sure when we will have it. But right now, for each of the module, we still need to have buy it separately. So if let's say we have a multi-protocol like our CMMT, right, then it's good that you just need to buy one module, and then like our CMMT, you can just switch the field bus according to your needs with just one same part number. Okay, and these are just some. Okay, we could have used FAS to connect, just like API, we can use FAS to connect to it. Then for our remote I/O, right, we actually have a Python library. So you could use the Python library and then straight away connect to our CBase API/O module and then to control it. So there is some addressing notes, like you can see this, like what is the address of the internet IP or the Modbus TCP address. Yeah, and also we support like MQTT communication, but to be honest, I haven't tried it yet. Again, this is the same like ABI as mentioned just now. Okay, so that's it's the same for ABI and ADA. It's more or less the same. The only difference is that it's modular and decentralized. Okay, then okay, so we have some. I will go through quickly here because I think it's better that you guys can try it out yourself. So this is when we are using CPX AEC with, let's say, our PLC, okay? So as mentioned here, later you guys look at, I'll send this to you also, you can see there's some comparison like why we are changing to AP system. So yeah, okay, this is, if you open the device, right, this is, this is just a question for you to identify. Like later you guys can try to open it and see yourself how the structure looks like inside.
Yeah.
Yeah, correct. Okay, so because when we connect with CPX APA, right, we need to know like how is the slot number assigned. So like because when you connect to remote I/O, right, your address, your first module will have the first I/O address. So you need to identify which is your first module. So when you assign for CPX API, right, the first module is always the interface module. Then the second module will start from the APCOM of the left port. So this will be the second module. Continue 0 like 2, 3, 4 until it ends. Okay, then we will count from the right port to 5, 6, 7, something like this. So this way you can identify how it is. But of course, you can also straight away connect to the web server. It will show you like how it was arranged. Okay, same for APA. So if let's say your APA, your field bus, okay, field bus is on the left side, right? Then it will start from 1, 2, 3, 4, 5, 6, 7 here, like this, just continuous. Okay, but your APA device is not necessary to be the first module. It can be at middle as well, like this. Okay. Then the calculation is still the same. Like it will start from the first device of the I/O module. So it's different with API. Like it see from the left and right, right? For OBA, it will see like from your whole set, right? So that means the first module will be the digital input or digital output module. Okay. So what if like you have additional API module outside? So how it calculates is that it will go from 1 to you will finish the counting for your base module first, 1 to 7. Then only you go to the API. So the API will be the last. If let's say you have additional API, then it will be 897. Okay. Okay, this is just an overview what we have supported. So we have COE, FOE, EOE, and the future one that we will be supporting later on. But again, we haven't heard of it yet because it's already quarter 3 and we still do not have a safety OE ticket. So just wait for it. Okay. So here is that it shows you like just an exercise that we do, like you can follow it to do like when you are connecting with a PLC, you can try to scan your internet device to get all the module. Okay, then I think I will not go through this. Maybe you guys can. I'll send this to you later. You guys can try with our PLC with like maybe the CPX AEC. Then you can try it out. What is mentioned here? That as mentioned, okay. This is access to the web server over EOE. So with this, you can, as mentioned, you can connect to the, you can enable the EOE and then you can connect. You can connect to the web server. Okay. Did it show you how to do it?
Yeah, I think you did.
Let's see. it didn't. Okay, then by later I can show you. Okay, but okay, then we also we also can have this EMCY diagnostic. So EMCY is a diagnostic that if let's say we have an error on our CBX API, right, or CBX APA, it will give a signal to your PLC, and from this way you can identify what is the error that is happening on the EtherCAT slave. Okay, but I won't go through details here. You guys try it. If you face any issue, then you can ask me. It did mention here like what you need to see already, right? So just the only thing is that it did not mention about the EOE, but I can show you to you guys how to enable the EOE later on. Okay, and then we also mentioned about we have a backdoor access, so you can connect to the output, and then you can assign the IP address, and then you can access to the web server, as well as you can connect it with your FNS. Okay, so that's for EtherCAT. Then we also have one for Profinet. Okay, so same thing. It gives you like some overview of like how the Profinet works and what you can do with the Profinet. Later you can try to configure this with our Siemens PLC. Okay, you can try to connect, then do some configuration or access to the web server. Basically, you just follow the exercise here, and it will show the solution here also. Then after internet, we also have Ethernet IP one, but in this case they are using the Rockwell. So with Rockwell PLC, they can do a lot more, but we don't have a Rockwell PLC. But you can still try to connect maybe with a TS PLC to the CBX API to give it a try. Okay, like it did mention like you can set the IP address here, or you can change the IP address from your FNS. How you can get something like how you can do the firmware update, whether through FNS, through FreeBSD tools, or through web server. So some way of doing upgrading firmware. You guys can give it a try. So to familiarize yourself. When it's regarding the RF logic, you guys can just skip that because we do not have Iron Valley PLC. But for other part, yeah, you can give it a try. Like, okay, so for example, in the web server, right, where you connect it with Internet IP or Modbus, you can find the register view here, how it looks like, yeah, all these things. But again, okay, so anyway, this is mainly for Allen Bradley. You can have a look. Then, okay, we also have one. IO-Link, okay. Using the, let's say we want to connect with IO-Link, you could have take one of the IO-Link device, okay, any IO-Link device that we have, then try with the IO-Link. You guys have a brief idea of what's IO-Link, right? So basically, IO-Link is a type of communication. Then normally for IO-Link, we separated into like podcast A and podcast B. So podcast A is without power supply and podcast B is with power supply. So our IO-Link master is all podcast B. Okay. Then in the configuration, right, you could have configured like the API and I think APA you could have, there is some way for you to okay, never mind, it's not showing. When you connect with FNS, right, there is a parameter that you need to configure for it to have the power supply output, because this is just for safety purpose. We don't want like people to randomly connect AP podcast A device to our podcast B, right? Then it might spoil their IO device or whatever. So that's why there is an enable button that you need to enable it for it to have the power supply output to the IO-Link device. Okay, so yeah, this one. So you guys know about ISDU, the service data? Any idea?
No.
Okay, so for IO-Link device, right, when we use the IO-Link master to communicate with IO-Link device, normally it's communicating through like what we call as process data, like because for example your IO-Link device would mention that I will have a 2 bytes input IO-Link device. So that's the process data that you are getting cyclically, okay? But ISDU means ISDU is more to like a cyclic data that for example if you have a pressure sensor, your current reading is bar, for example, okay? Your current reading is bar, but for most our pressure sensor, like our pressure sensor, right, you can change the display unit to whether you want bar, you want kPa, or you want millibar, for example, okay? Then you could have used the ISDU as a cyclic data to override this value. So basically, like a cyclic data to change this parameter from, like let's say current is reading bar, you can change it to kPa, and then your process data will change to kPa as well. So that's what we call as ISDU. So that means you other than the process data, you could have changed the parameter inside your IO-Link device through the IO-Link communication. Okay, so I believe inside here you see there is some there's some exercise like a solution like how you can do it with whether Codesys or TIA, how you can do it. So I will leave it to you guys to look at it later on. If let's say you have any questions, not sure, then you can ask me. Okay. Because I think these are more to something that you need to try it yourself, you need to do it yourself so that you will remember. Okay, so yeah, this is basically all the IO-Link. Okay, yeah, okay, I think that's the exercise for today. Now you try with the EtherCAT. So the three different exercises that we have: EtherCAT, Ethernet IP, and then Profinet. You try with each different PLC to communicate with our like the CPX APA. It can be whatever. You can just plug and play yourself later on, whatever.